Hi, we're about ready to get started with our third talk session. We have George Rice here, and he's probably going to tell us why we're glad that Python is being used in the Joint Strike Fighter.
Thank you very much. Thank you everybody for being here. I want to tell you a little bit about the F-35 Joint Strike Fighter program, also known as the Lightning II, and how we're applying Jython to enable the system software developers to automate a lot of their tasks and get the tool developed or the product developed much more efficiently and much quicker. So first of all, I'll give you 2 or 3 slides on what the F-35 Lightning II Joint Strike Fighter deal is all about. Then we will talk about the need for an embedded dynamic language and some of the custom tooling that is used for system and software development, why we picked Jython. I'll look at 5 use cases or problems that we addressed in making that power available to end users who may not be software type of people. Also, 2 things that we would like to have and don't really know how to do yet. If you know how to do them, talk to me after. We'd love hearing from you. Talk briefly about implementation and deployment, and then we will conclude. So the F-35 is what we call a 5th generation fighter. There are 2 characteristics that we think represent a 5th generation fighter. One of them is called stealth, or low observability. That's being invisible to radar. I'm not going to talk about that this morning. The second is very advanced electronics. The JSF integrates with an ad hoc battlefield network that allows it to communicate with all the other assets that the Allies have on the battlefield, so that it has great situational awareness as to what is going on the field. Those electronics require a lot of software. Millions and millions of lines in the air and millions of lines on the ground supporting it. So we have to be able to support this aircraft efficiently. In addition, complicating the problem is that there are actually 3 different versions of the airplane. In the upper right corner, you see the conventional takeoff and landing. That's analogous to an F-16 or an F-15. It's what the United States Air Force uses. It will also be used by most of our foreign partners, such as Italy, Australia, Canada, whoever. There's also a second version in the upper left-hand corner of a carrier variant. A carrier variant is used by the United States Navy on its aircraft carriers. And it has a few changes from the conventional takeoff and landing version. For one thing, the wings are larger and have ailerons on the end. This allows it to come in for landing on the aircraft carrier much slower than a normal aircraft would be able to. In fact, the slower that you go, the safer it is for the pilot. And understand that that's one of the most stressful jobs in the entire planet, even more than talking in Python. It also has, let's see, what was the second thing? Oh yeah, the wingtips fold up, so we can pack these suckers like sardines onto the deck of an aircraft carrier so that there are more aircraft available to run missions. And the third thing is a greatly reinforced undercarriage and a tail hook. So when the airplane crash lands on the aircraft carrier, the tail hook, we hope, grabs one of the cables and stops before it reaches the end of the flight deck. The third variant is the really sexy one to me. That's the version that takes off like a helicopter, flies supersonic, goes and does its mission, comes back and lands like a helicopter. The only other fighter in the world that does that is a Harrier. The Harrier uses very different technology. It redirects engine exhaust out various ports around the aircraft to make it fly. We take the jet nozzle at the end on a 3-bearing nozzle and actually swivel the entire nozzle straight down, so the exhaust is lifting the back of the aircraft directly. In tandem, we have a rotor that comes out the front of that engine that drives a fan right behind the pilot's head in front. That provides air in the front to lift it up and keep it airborne. This is used by the United States Marine Corps, as well as the United Kingdom Royal Air Force and Royal Marines. So all of those different variants we have to deal with in making the system work. Now the pilot of the JSF has a giant super HD TV in his cockpit, one giant big screen TV. It's touch sensitive, has a windowing operating system driving it, not Windows. This is a real-time operating system, very reliable, no control, alt deletes allowed. The pilot is able, through a mission planning system on the ground, to plan out which views, what kind of data he's going to want to see. He can then call it up at the touch of a button. The pilot has a second display, which is mounted to his head helmet. And so the computer is able to track exactly where his helmet is, and through sensor fusion, if there is a threat that's flying out here, he can circle it on his helmet visor and put all the information around it. And as he moves his head, that circle will stay in place over the target. As long as we're doing displays on the pilot's faceplate, at night, because we have so many sensors, we can actually synthesize what he would be able to see if it wasn't so darn dark outside. So we can do that. In fact, you can actually look straight down and see through his airplane and what's on the ground below him. So that's what I've been working on for the last 12 years. I'll show you a little video that will show you how these things work. Hope you will forgive me for injecting comments occasionally in the video. That's my baby. That's the 3-bearing nozzle going down. See, it does actually go into the top of the This is our factory in Fort Worth. It's about a mile long, about 500 yards from where I sit. We have giant cranes that run along the top. They actually pick up the aircraft and move it around. Sometimes they have its first flight, but it's just hanging over the paper. We have special software used in the factory floor that allows us to test control services and other things. The guy you'll see sitting in the cockpit here in a minute is our legendary test pilot, John Beasley. He's actually the first guy to have the government plasma screen. This is engine installation. Now, sometimes expected something more sophisticated than a car. They just run in and wind up in there. But I guess that's it works. This is testing the ejection seat. That's not a real person. Nobody volunteered. This is rollout, always a banner day for any aircraft. Get some shots of the cockpit in operation here. This is a helmet display. This is a simulation of what you can see if he was a cowl. Turn his head all the way around and look back to the seat. In a moment, he looks straight down. The electro-optical tracking system uses the sensor of the aircraft that allows it to track targets. In this case, he's actually bugging a couple of joggers running along the wall. The aircraft will keep track of him and he's no longer in. That's what gets me up in the morning to go to work. Would you believe all that software is written in Python? No. Neither would I. It's actually written in C++. We do use Python on a lot of the tooling that supports the development of the software that goes into the airplane and to the ground support systems. We'll take a look briefly at 2 tools that are kind of at the opposite end of the spectrum. The first, on the left, is a signal interface management system. It is basically a configuration managed database that tracks all the different interfaces that are used on the airplane, from wires to messages between the different software applications, as well as feeding down a lot of downstream processes, about 14 different downstream processes. I was going to demonstrate it to you. I actually had it installed on the system and on my little laptop, and it was working just great until last night when it stopped working, and I'm not enough of a database wizard to know why. So this is my Dilbert moment. If the tool was working, you would see a window over there and a window down there, and you would say, I've got to get me some of that. It's a very big application, very sophisticated. It's custom, and it costs quite a bit of money. It's written in Java. Now, on the right-hand side is the opposite spectrum. It's a very small tool called a message routing system. We don't use internet on the air vehicle because we have to make sure that every message gets where it's going, exactly when it's going to get there. Therefore, we pre-route every message on the air vehicle. To do that, we have a tool called message routing. Creativity in naming tools is not really our strong point. The message routing tool reads an XML file that's dumped out of SIMS, so we know every message is going to be on that aircraft, where that message starts, and where it needs to go. The heuristics in the message routing tool make a best guess at how it should get there. Let me show you. It's easier to understand by seeing. So here's every message that's on this particular version of the aircraft. So there are quite a few of them, a whole lot of them. And then this particular message selected starts from these two applications, and it starts from the first, it may go to one of these three applications. And if it's going from the first application to this application, these are all the possible ways it could get there. Now the tool I selected, this one is the best method, but in some cases there are reasons we don't want to use that routing, we may want to use a different routing, maybe multiple routings. So the tool will allow the user to go through and select the best route for each message. As you may guess, as we do more and more builds, there are a certain number of exceptions to the rules that are built into the tool that come up. For a while, they had a list of these on a piece of paper, Post-it notes stuck to the wall, so they would have to go through, find those messages, and make the changes. That burns a lot of time, and it's getting bigger and bigger. We could modify the heuristics in the tool so they did a better job, but it seemed better to us to allow the guy that was actually making those choices to write code and automate his own rules into the system himself directly. That way he gets the turnaround time of maybe an hour as opposed to several weeks for actually modifying the tool. The reason I said they're at opposite ends is because of the number of users. There are about 1,400 users of SIMS on a given day, about 250 of them are using the tool. It's used about 53 sites worldwide. Our partners are helping us to develop this aircraft. Miro is used by 5 guys down the hall from me. They're the only people that use it. In the first case, we're really trying to save a lot of money by automating work. In the second case, we're really trying to get builds turned out faster, because the amount of time it takes us from the time that we dump data out of SIMS until we're actually testing in the lab is a big driver on our costs. So GUIs make the tools easy to use. We all know that if you have a GUI, it must be an easy tool to use. But we also want it to be efficient as well, particularly for more technical users who are able to do things. So we looked at our commercial tools that are in the system software and development environment. And it turns out it's about 90% commercial and 10% custom tools. There's some tools you just can't buy for doing special F-35 stuff. And almost every major tool had embedded scripting. A lot of them use Visual Basic. A few of them use JavaScript. There's actually one that has Python in it. And so we thought, you know, what we really need is a good embedded scripting language so these guys can automate their own work. So we set out some criteria. We want a tool, a language that is popular. We want to be able to go down to the local bookstore, buy a book, and learn that language. We want the language that we selected to have long-term promise, have good, strong community supporting it. It had to be easy to integrate with Java because like anybody, we don't have much money to go implement this thing. And we have a bias toward commercial licensing. I know that's not a very politic thing to say at an open source type of conference, but we're a big corporation, so we have the comfort factor when there's a commercial license behind it. In 2004, when we actually looked at these, or maybe it was late 2003, we thought there were maybe 5 players. One was Jackal, which is a TCL implementation. There's no other tool in the program using TCL, and it didn't really seem like it was an up-and-coming hot new language. We also looked at Bean Shell and Groovy, which are implementations of Java as a scripting language. And that looked like it would be pretty easy to implement. The problem was, of course, these tools are written in Java, so we already knew what the API looked like for Java. It's kind of big. These are the classes. The problem is if I show these to a hardware wiring kind of guy, he is going to panic. Or maybe slug me, I don't know. This is the actual Jython API that we use for SIMS. As you can see, it's just a little bit simpler. So we were looking at something a little bit simpler. Looked at JavaScript. There was a JavaScript on Java version in development, go figure, called Rhino, but at this time it was still struggling along. We weren't sure if it was going to be a long-term survivor. We figured JavaScript would survive, but whether Rhino would survive or not was kind of questionable. And then there was Jython, which had a very popular syntax. We thought that Python is an up-and-coming kind of tool, growing in popularity. Already in use on the F-35, CPython in certain other areas. The only thing was the project seemed kind of stalled at 2.1, didn't seem to be moving forward, but it seemed to work as it was. So, you know, maybe stability is not too bad of a thing. There was no commercial option available at all for putting scripting into a Java application. I was kind of surprised by that. There was also no runaway best choice. But in the end, we chose Jython basically for 4 reasons. One, Python seems to be an up-and-coming language. We thought that that would be acceptable to the users. We did Jython, actually I did a Jython prototype, and I'm not a Java programmer. I can make the thing work, anybody can. So it had to be fairly easy to implement. It had an interactive shell, which we thought was a big plus for people learning not only the language, but also the API we were going to give them for these various tools. And then there was the source code analysis. When a big corporation wants to use an open source tool, we have to prove that there are no copyright issues with that source code. Therefore, over here on the right, you see a spreadsheet where we listed every file in Jython, all 338, track down who wrote it, how they licensed it, whether there was any intellectual property type issues, copyright issues really, with that code. We found 2 files that were questionable. We were able to find replacements for those 2 files. So we built our very own version of Jython and said that's definitely the way we want to go. Looks like it doesn't have anything holding us back. Okay, so the 5 things that we wanted to address are listed here, as well as that you wish we could. I'll walk through those one at a time, along with a few demos. The first question was, when you get a script, like you get one in the mail or whatever, and how do you get the thing installed? You know, the last guy I was talking to, I thought, it was getting buzzing from his phone, so I turned my phone off, and that's my clock. So I have no idea how much time I have left. I guess we'll find out. The best laid plans and all that. Okay, that's good. I'm about where I should be. So the first question was, if you get a script, how do you actually install it into the tool? If you get it with someone else. Now, Firefox has this really slick, plug-in thing. We have dialogues and websites. You can go through, pick things, you can install it and manage it for you, and all that's really great. But like I said, we have a limited budget. We wanted something that was very cheap and inexpensive, but would be very intuitive for the users to apply. Well, users know how to copy files from one folder to another, so why not have a magic folder where the tool will look, any file it finds there is a script that it wants to run. So to make that easy to find, we add it to the menu. So this is the sim, you get tool, open folder, scripts. And that just opens your native file browser, and each script that you drag and copy in there then works just great. So in Miro, I'm going to show you the installation process. It's terribly difficult. Just to show there's nobody behind the curtain. There's nothing here having to do with bookmarks, right? Okay. So, you open the scripts folder, and there it is. I have some bookmark code here. This will give you a good example of what a Jython script looks like. Oh wait, I've already done it here. Here it is. So basically all this code is doing, I'll show you from the top. There's a little bit of setup, boilerplate there, but the money code basically goes through every selected message. That's what this is doing right here, and writes the identifier for that message out to a text file. So that's setting bookmarks on whatever message you have selected. The code that does the selection, the converse of this, just reads that file and reselects the messages you had set when you last ran the script. So that's pretty much all the code there is. It shows you you don't need to be a Java expert to write Python code. So what we will do is copy this entire folder that has the 2 scripts in it, called bookmark, over here. And that's the installation process. So now if we look under Miro, we should be able to select a few messages. Like that. Under Tools, Scripts, there's our bookmark folder, bookmark set, and the script will run. Now my bookmark has been set. I can now bookmark, select, and they're reselected again. So very easy for an end user type person to automate whatever they need. This is actually a capability that end users were asking us to put into the tool. We just thought once we got Python in it, we'll just give it to them in the easy way. Okay. Now you may wonder, look at that tool real quick again. There we go. You notice when I hover, I get a tooltip. It has the version number and an explanation of what that script does. So, our question was, how do you make that easy for the end users to set up? Well, what we actually did was say, okay, we'll put some tags at the top of the script. Script is just the menu item that will go onto the menu itself. The version number, there's the menu item. And the version number will go in parentheses as the start of the tooltip, and then whatever's on description thereafter will go with the rest of the tooltip. That allows the guy to document his own script in one text file without having to re-implement Firefox. If they don't put that at the top of their script, they get a file name. If you want to be user hostile, darn it, you can be user hostile. We had some concern over turning people loose with the scripting language in this massive database that is like central to our entire system and software build process. Because if they wrote a script that kind of went wild, heaven knows what they could do. We wanted a way to protect us from that. The concept we came up with is the concept of a draft. A draft is a record that's not yet committed to the database. It belongs to that user. No one has to modify it, so they can see it. And it has some properties that make it more useful when it's being generated out of a script. Let's see, where are those properties? I wrote them down. It does have a 10-level persistent undo. So you can go back to versions that you saved several days ago. You can do a compare of 2 of those earlier versions in a visual diff. If you want to restore one of those, you can pull it back and make it the current version. It also has a capability to merge, so that if you have 2 earlier versions you want to take apart from each, you can pull all that forward, just the parts that you want. We're also George Orwell's biggest fan. Because the Sims tool runs from a server, we track everything the users do with their scripts, because we're really paranoid. It's what we're paid to be. So we collect lots and lots of metrics, which actually come in useful, you'll see a little bit later. We also added the ability, if a user is just hopelessly clueless and keeps scrubbing things in the database, we can actually turn off his ability to run scripts. We just raise those suckers right out. So that's our fallback position. With that in, we were able to convince our management to let us add scripting to Sims, even though it's very critical to the program. I think it's important when a person is first learning a tool to be able to write print hello world and have something useful come out. So in order to make that happen in an embedded type of environment, when you start printing in Python, you start seeing, don't forget to point to my screen. There's a dialog that pops up that has whatever you print in that script come up. You can drag, copy, and paste, and you can save that. If you have an exception in your Python script, it'll come up in red in that same window to make it very obvious that that was not normal output. That was pretty darn abnormal. That was in Sims. Now, when we got around to doing Miro, which was our second implementation, we had noticed that a lot of people were asking how you go about using swing. It's not my phone, I promise. How do you go about using swing to generate a progress bar for scripts that run a long time? So when we got to Miro, we actually put in a built-in progress bar and status line that the script controls completely. It has the cancel button on it. There's a little progress bar and the script control, go backwards, whatever you want it to do. So using that, the users don't have to go off and worry about a lot of swing. There's just a little bit of code necessary to control that. This is the script that just ran. In order to put a status message up on the bar, you just need one call, which is message. Just like a print function in Python 3, we were ahead of our time. And then there's a bar function. You give it an integer from 0 to 100, and that is the value of that progress bar. If you go outside, it just prompts it. So that makes it very easy for the users to make their scripts user-friendly in certain ways that count. For power scripters, we added a few capabilities that enable them to do sort of magic things. We did put the Python shell in. Basically, you just go to Tools, Python shell, and you get a Python shell. Not very hard to do at all. And we have all of the API available from there so they can learn the API. In addition, there's command line options so that you can set up one or more scripts to run when you first bring up the tool. You can do some pre-setup for you that you would normally have to do automatically. And then very important for people who want to run long reports early in the morning before they come in, so those reports will be available. You can also bring up Jython independently from a command line and access these tools without bringing up any GUI at all, or not. And therefore, you're able to do those things basically from a cron job or from a scheduled task in Windows. The last thing that we really wanted was the ability to do automatic updates. Kind of like Firefox, will sometimes say, there's a new version of the script, let me install it for you. Well, some users, because we have a lot of scripts that we gather together that are generally useful to a lot of people, wanted to have those automatically maintained for them. So we thought about modifying the tool to do that, and it occurred to us, hey, Python is a programming language. We can do that in Python. So one of my hot young programmers named Jason went off and wrote daily update, a little Python script that when it comes up, checks to see if it's already run once a day. If it hasn't, it goes and checks the website, compares it to what you got. If there's anything newer, it sets it up for you. So that was our first use of that little capability. The two things we don't have that we really like to have. The first is the ability to record a script by turning on recording, clicking on some stuff, turning off recording, and looking at what you did in Python code. Now we could probably do that, probably would have if we had known that we were going to be embedding Python when we started these tools. It's a little hard to retrofit. I don't know of any magic that would make that easier to do. We basically have to go reverse engineer every click and turn it into Python code so we can generate that. But it's very handy for someone who's just starting out to see what the code is when I click on something, and also to build up a quick framework to get you started in what you're doing. The second thing we really like to have is an integrated environment with debugging. Right now we debug with print statements. That's not really the best way, but although we've written some very sophisticated scripts without it, it It would be really nice if when we hit an exception, if a debugger popped up and showed us a line with looking for things like that. It'd be really nice if it happened to be based on Eclipse, because we use Eclipse for our Java development, but almost any IDE would be fine. We kind of feel like this is on the Jython guys. If they want to play in the embedded scripting environment type thing, you really need that kind of capability built into the tool.
Did you try, so you say it doesn't work with Jython, did you try PYDef and the extensions that that'll be debugging Jython?
No, we did not. I didn't quite understand everything that you said. I think that you all...
There's a module where
It's called PYDef.
Yeah, it's called PYDef.
PYDef.
Yeah, there's PYDef and there's PYDef extensions, which is like a semi-commercial version.
Excellent. So PYDef is perhaps a solution to this. I've already made my trip here worthwhile. Ms. Solomon, thank you very much.
I don't know if we're doing better.
We won't know until we try. Okay, so how much did it cost to implement this stuff? Well, for Sims, the client side used 10 Python classes with 173 methods to wrap Jython so that it would be a very clean and elegant type of user environment. It took one developer about 10 months to do that. His name was George Clark. He did a really good job. Now, that may sound like a lot to an open source developer. We're in a corporate environment. We have to go through a lot of requirements and design. We have to plead for money, get more money, that sort of thing. So that was the total cost for providing that capability and deploying it out to 1,400 users. Miro was about half the size of the code, but obviously it required about the same investment. I'm not really sure exactly what it was. I was kind of surprised when I looked at the numbers for this meeting. But that kind of gives you a feel for what it takes to implement this. Was it worth it? Heck yeah. With the Sims stuff, we've already probably saved that and more in terms of user productivity and getting things done. Thank you. And with the Miro tool, the message routing tool, we've actually speeded up builds quite a bit. So this has been very successful in this environment. I told you that we're Big Brother, and we gather together tons of data on the Sims users who are running scripts. So we can generate little metrics like this. So there are about 50 people who have their scripting enabled right now. We actually do it backwards from what I originally implied. We require them to go through a class on how not to destroy the database before we turn on scripting for them. So you have to ask for scripting before you get it. About 50 people have gone through the pain of that class. It's about an hour before we turn it on. We have about, on any given day, about 10, 15 different unique users running scripts. They run an average of about 50 scripts a day, although you can see it peaks somewhat over 100 on some days. This is from last year. I'm looking for new data from this year. But the usage has been growing. So, I can say with some authority now that Jython does in fact work well in a big project, proprietary, custom tool type of environment very well. There's some additional players, which I shall not be named here, in the Java embedded scripting world, but we still feel that Jython is a very competitive environment. We're very happy with our choice. One of the best testimonies we got was a person who opposed putting scripting into the client tools. He said that it's just a gold plating, it's not worth doing, but we did it anyway. And recently he had to migrate an awful lot of data in Sims, and he had the class to write to us and to our boss and say, no, I was wrong. We really did need this, and we could not have migrated our data without Jython being available to do it. So, testimony from an outsider, ourselves. Usage is increasing. In addition to use of Jython and some of the embedded tools or some of the custom tools has also increased in interest in using CPython. It's seeing more use. In fact, our legal guys went out now to go do the full release of full CPython so that we can deploy it more widely across the program. So we're looking forward to Jython 2.5 and 3.0. We did not upgrade to 2.2, but we didn't thought there was enough incremental advantage there to justify the cost. But 2.5 was really a nice choice. Wanted to acknowledge those people who helped with the project as well as me with this charge. In particular, at the bottom, Karen Hager, when I found out the first of the week that it was a 2-month process to get permission to release data, and I had 4 days. She called me while I was sitting back there and told me I had permission to stand up and talk, otherwise this would have been a very short presentation. So kudos to her, and boo on me for being so late in requesting permission to do this. Okay, so we should have a few minutes for questions. If anyone has them, I'll do my best to answer them. Otherwise, I did such an exceptional job of explaining it to you, you have no questions whatsoever. Stop. Yes.
What runs on plane themselves? No Java.
There's no Java on the airplane. We actually, I'll tell you a short story since we have a couple of minutes. As we were developing the software development environment back before we won, the customer came down and had talked to Sun and So I had to convince them that C was an obsolete language and we should be doing the airplane in Java. So I got the task one morning in 2 hours of putting together a rebuttal to Sun to explain that Java was not really appropriate for a high-speed real-time environment, mission critical. So they accepted our work. So it's actually done. C for the really safety critical stuff like keeping the airplane in the air, and C++ for those mission software that makes it into a fighter plane. Lots and lots. Yeah.
Would you say your end users are?
They're the system developers and the software developers of the software that flies in this airplane, as well as things like autonomic logistics, tracks spare parts for the airplane, the training systems, the test station users, those kinds of people. Yeah.
Is there no ADA on this plane?
Would you like to program an ADA on this plane?
I just did it. I'm working on a couple other ones. I'm kind of shocked not to hear ADA.
It's a very good question. That question came up once or twice. In fact, my very first project lead on JSF was back in 1996 when we did an ADA 95 study to see if it would be appropriate for the airplane. You know, ADA is a fine language. I personally love the language. It's very good for safety critical type of work. The only downside is when you bring in a young engineer ready to change the world out of college and tell them, you get to work in ADA, and they're like, no. It's not something they want to put on their resume. So, no, as far as I know, there's no ADA on the airplane. Primarily because C and C++. We use a subset of C++, a safety critical subset that we work with some international committees to kind of standardize. I don't remember exactly what we call it. But we're not using things like dynamic memory allocation and such, which are very bad to do in a mission critical type environment. Yes, sir?
Leave all the data software.
Excuse me?
All the data software.
It could be. That's developed by Pratt & Whitney, and so they don't actually use our tool set, so I don't know. I'll take your word for it. As I said, it is a fine language, very, very good real time and safety critical. Yes, sir? That didn't actually play the decision. SIMS does use Corba communication between the client and server. It's actually a fairly old system. SIMS has been around since 1997. Long before Java had a better enterprise environment. RMI, we didn't really want to base an enterprise customer on it. And we would love to upgrade it if we could just convince IT to give us some money. They say it worked for us, so much. Jython does work very well. Guys, I thank you so much for coming out and listening to me.